All right, so we're live. It's been a month since our last meetup. We have quite a few people here tonight, and I think everyone on the call tonight is from a different place. We're all in the United States, but we're all in different states, so it should be a fun group. Should we go around and just do a quick round of introductions, and then we can jump into projects or topics? Why don't we start, John, do you want to start us off with intros?
Sure. I'm John Karstens. I live in Idaho. It's a super fun place. I work for SmartRent on the embedded team and actually get to do nerves full time, which is pretty new, like since March. So that's been fun and exciting and joyful mostly. And I like working with, I've become really obsessed working with hardware, and especially like the most random, nonsense, useless projects around my house. So that's typically what I bring to the table in these meetups.
I think that's the end of the intro. Sorry, I actually can't hear John's audio. I don't know why. I'm hearing everyone else. I think the recording will still pick it up. So this is probably just me having a fail.
I don't know why. I'm hearing everyone else.
Todd, do you want to take it?
Yeah, sure. I'm Todd, resident, and I'm in Castle Rock, Colorado, just outside between Denver and Colorado Springs. And I work at a company called Weed Maps. And I tinker around on embedded stuff whenever I get free time, which is not as much as John. But I definitely enjoy the inspiration that I get from this group. Currently working on an air quality sensor with my very piss poor soldering. So that's an air quality sensor, and I got a very tiny fan that I'm going to run at as low a voltage as I can so that it goes nice and slow as the intake, so that I can get fresh, like room air passed across the sensor, and then matrix for the output, and then I'm got a walnut box and a white acrylic front and back for it that I'm working on. So I think that's it. I don't get paid to do nerve stuff, so I have to find time to do it outside of work hours.
Awesome. There's not enough of us who are getting paid to do nerves work quite yet. Ganesh, do you want to take it next?
Yeah, sure. So pretty new to nerves, even Elixir relatively. A lot of interest in there. Since I was in the last meetup, I have got a Raspberry Pi 3 and trying to run the nerves on there. Running the Phoenix on the nerves. I even attempted Phoenix 1.4 on there. I opened an issue also there on the 1.4 because the example I could run on 1.4 wasn't running, but I got it to work. So I'm happy I'm making some progress on there. And it's very interesting.
Awesome. I missed the last meetup, so it's good. This is my first chance to meet you, so good to meet you.
Oh, yeah.
Aaron, do you want to intro?
Sure. My name is Aaron Renner. I live in Bayfield, Colorado, which is southwest Colorado, about an hour to New Mexico in that area. I currently work for Active Prospect, and I'll be joining Dockyard here in mid-July. I don't get paid to work on nerves, but I did take a little Raspberry Pi 0W to make sure that my neighbor's freezers that hold a bunch of beef in them don't get unplugged, because I accidentally did that for a while. So, or I accidentally unplugged his freezers, and that's like $2,000 to meat in there. So, anyways, yeah, I'm happy to be here and learn more about nerve stuff.
Awesome. Ben, you want to do a quick intro?
Sure. So my name's Ben. I live in lovely Austin, which is a fun place, but I'm originally from Colorado, like so many people here. I also don't get paid to play with nerves, but I just kind of play with it on the side. So it's one of those things that I'm always looking for useless household projects to work on. So.
Maybe that should maybe become the tagline of the meetup: useless household projects. I think a lot of us
That's the best
have done some
kind.
of those. John calls them dadgeneering projects. Manuel, do you want to give a quick intro?
Yeah. Am I coming across? Okay. All right, cool. So yeah, my name is Manuel. I live in New Orleans. I work about 50% in Elixir Phoenix projects and 50% DevOps. Outside of that, I've been doing a lot of household projects with nerves and controlling lights with the help of Home Assistant.
Cool.
All right. Sorry, I'm still having a couple audio issues, only with a few of the audio streams. So who knows? The streams are crossed somewhere on the internet. So tonight's topics, we have one planned topic. I was going to give a quick intro on how to get an InfluxDB and Grafana device set up really easily. I actually do it without nerves, which is slight blasphemy for this meetup group. But I love to have the cheapest possible UI, since I am really terrible at UIs. So I'm going to run through that, and then I figured we could just open it up for anyone else that has projects that they're interested in. So I'll share my screen real quick. This should be fairly fast. I don't have a whole lot to say, because I did eventually find a pretty fast way that I think will be pretty simple for other people to follow. So there's this project called Balena Cloud. It used to be called Resin.io, if anyone was familiar with that. And it's kind of, I think the easiest way to describe it is, if you have any background with web development, it's Heroku for your own devices. And so the idea is that you started a project, and then whenever you want to provision a new device, you can just choose your device type. You set a version, and then if you need to provide any Wi-Fi credentials, you provide them here, and that will generate an image for you that you can download, burn to a SD card, and plug in. And when that connects to the internet, it will automatically start trying to check for a new version of code to download and start to run. And then you can build a project using Docker containers. So anything basically that can run on the ARM architecture of your Raspberry Pi is fair game, and you can use whatever languages or tools you want. So in my case, what I was trying to get to is I have these little pots, and I have a capacitative moisture sensor in each of them. And then I got, after this picture, I got two more of these little pumps. So these are just like little 5-volt pumps. They can run off of USB power, which happens to be the same power that a Raspberry Pi needs. And I hooked these up to relays so that I can turn them on or off and pump some water in. And these are like, on the end of these clear tubes is a drip line. And that drip line will just help to kind of let the water seep out into the soil. And so what I wanted pretty quickly, I could get to the point where I could read the moisture as like a percentage, but I didn't have any idea of like were the percentage is very accurate, were my readings fluctuating a lot, or are they very consistent? And I wanted to answer a bunch of questions about how accurate these are, what percentage of moisture related to like what I would think of as a reasonable amount of water for a plant to try to grow. And so I just wanted to get some sort of UI running. So there's a project. If anyone ever wants to build this, you can always come to mmmreese/BalenaStats. I forked this from a project that the Balena people published, and they have an article in here. Actually, I think I linked to the article right here. So this blog post will take you through like all the down and dirty steps. But essentially, their project is just about hooking up kind of an air quality sensor, and then having it report to InfluxDB and hooking up Grafana to that. And so I just forked their project, and wherever in the instructions it tells you to git clone their code, you just git clone this repo instead, and it takes off the Python code that reads the air quality sensor and replaces it. And it also makes a couple of small tweaks so that InfluxDB will listen publicly for on its UDP port, so that any other device in your local network can just start publishing some stats, and they're going to become available. And from that, you can get graphs like this. So this is my little Grafana instance. This is the last 8 days of moisture readings in my pots. You can tell I have not been watering them. I'll get into that a little bit later. But some of the cool things that Grafana gives you is this ability just to like dive in through your data. You can make different kinds of visualizations. And basically, any device on your network that starts reporting numbers, you can just turn those numbers into metrics or visualizations pretty much any way you want. And that's kind of what I was after in this project. But interestingly, I think it's worthwhile here to stop for a second and point out some of all the things that can go wrong when you are building things in the real world. So problem the first was I got my my relays hooked up. I turned on the power to one of my pumps, let it run for about 10 seconds, and then turned it off. And I was watching the sensor readings, and I'm like, oh, that's really interesting. One of my kids needed some help. I ended up not getting back to the project that night. And in the next morning, I opened up my dashboard to see what the moisture levels looked like from the night before. And it was like pegged at 100% moisture. And it had been all night long. I thought, what? Like, it should be getting less wet overnight, right? Because like the pump's not running. And I went outside and I go look at it, and it's completely flooded. And I'll just reshare this really quickly. It turns out, I don't know if any of you will have ever done this, but if you've ever siphoned liquid from like maybe out of a gas tank to another car, because this clear little bucket that I had full of water, the water level in this was higher than the water level in the tray where the pots are. And so even though I had turned off this pump, it still had water in it. And the water wanted to go to the lowest point of gravity possible. And so the pressure on the surface of the water here was higher than the pressure on the surface of the water in the base of this clear container. And therefore, water was slowly seeping through this thing all night long. And I made a mess of the floor of my garage. So that was one first failure. And then I learned about all sorts of other failures too. So one of them was that I noticed after I watered that I would get really consistent readings. And I thought, oh, I wonder how sensitive these readings are to where I place the sensor in the pot. So the pots aren't that big, right? There's not a lot of room here. And all I did is I went through after I watered all these, and I just moved the sensors from basically one part of the pot to another, but the same distance away roughly from where the water had been put into it. And this is the change in readings. So one of them went down, all the other ones went up, and this one went from like, I think this was about 60 or 70% moisture to 100. And so it turns out they are very sensitive to exactly where the water molecules are, more so than I thought. Another thing I found out was when I first got my Grafana up and running, I noticed that I would have these big gaps for like a couple minutes at a time. And at first I thought, oh, I wonder if the code that reads the sensors is like timing out, or maybe a gen server is crashing, like something, maybe my Nerves device is restarting itself or something like that. So I put a bunch of logging statements all over my Nerves code, and I come back and check those, and I see no gaps in the data there. And it turns out, after some investigation, this Raspberry Pi that runs InfluxDB and Grafana, it was really close to the wireless router, so close that sometimes it would actually have like interference or something. And so it was actually dropping its Wi-Fi connection and then coming back. I didn't even think to debug that until I went to try to refresh the Grafana page, and I got like couldn't find the server error in my browser, and realized, oh, it's the Grafana device that is falling off the network and then coming back on. So those things happen, and then you try to learn from them. And so I still have some improvements that I need to make, obviously. My next plan is that I'm going to make sure that the pots sit on top of the reservoir of water so that there's no chance of water continuously draining into the pots. This should avoid things like floods. And I will also make sure that I never put enough water in the reservoir that I could flood or cause any sort of damage to my garage. That's maybe a good lesson number one for anyone doing project in the physical world for the first time. And then I might also try out resistive moisture sensors. So capacitative and resistive moisture sensors are kind of the two big classes of fairly inexpensive moisture sensors. And I went with capacitative, and they're so sensitive to like exactly where it's located that I don't have a lot of confidence that I can actually maintain sort of a healthy moisture level. So I'll try out the other ones. I'm going to trade some hardware with Steve Newell, who he's in the Meetup group. He's not on tonight, but he and I get together, and so I'll trade him a touch screen for some resistive capacitor or resistive sensors, and then take another swing at it. So maybe next month I might have a little bit more of a success story around watering plants. But so far the score is my wife's plants are doing awesome with no automation, and I have flooded and subsequently droughted all of my plants so far. So automation 0, human beings 1. We'll see if we can even up the score next month. So anyway, I hope that's a good, just kind of quick setup. If anyone else is doing things with sensors, just having some sort of like history of what the sensor values are and stuff like that, I think can just be a great add-on or a great cheap way to get a UI up and running so that you can play around with devices in your house and not necessarily need to add a whole Phoenix or a database or some other persistence layer. You can just kind of reuse a project that already exists. Anyone else have a project that they're interested in? Yes, Manuel, that is very true. Clearly the solution here is more automation. That will definitely ease the problems of my project.
I was wondering, what's the difference between how the capacitive and the resistive moisture sensors work?
So I only understand a surface level of this. So big asterisk, take it with a grain of salt. But from what I understand, they're both just running a very small amount of current through a device. One of them is trying to pass a small amount of current from it kind of has these two prongs that go into the soil, and it's going to measure what's the resistance of electrons passing from this point of this prong to the point of this prong, and then it basically, however moist the soil is, it becomes easier for those electrons to flow, and then it tries to provide some normalization to those numbers so you can get a sense of in this entire length of soil how many water molecules are there that are helping the electrons to flow. With capacitive sensors, they kind of, well, you guys saw, it looks like basically kind of a long stick. And if you look carefully, you can see that there's a bumped up trace. They seal the whole sensor with kind of like an epoxy. So you don't see the copper, but you can kind of see the copper trace underneath the sensor. And what it's actually measuring is the capacitance between these two big strips of copper that are running around the outside of that stick. And similar to what happens with the resistive sensor, however many water molecules are in the area of the magnetic field that is formed by current running through those two traces will change the level of capacitance that you measure. And so in both of these cases, there's already a lot of resistance or a lot of capacitance, and how much, like, the water doesn't affect it a huge amount. And both of these types of sensors try to normalize those values so that you get out readings that are kind of 0 to 100%. And I did a little bit of testing with the capacitive ones of like leaving it in dry air, dunking it in water, and you do get almost like a 0 volt all the way up to almost a 3 volts value. And so I did a little bit of calibration, but not a whole lot. And so that's as much as I know about. I don't know why water molecules change the capacitance that you measure in that case. I just read the voltage, man. I just work here.
Do you happen to know what type of sensor FarmBot uses?
Oh, sorry, Aaron, were you asking me a question?
Yeah, do you happen to know what type of sensor FarmBot uses?
Oh no, my audio issues are back. Any chance you can type it in or someone else can repeat it?
Can you hear me, Mike? No.
Can you hear me, Michael?
Yeah, I hear you, Todd.
He's wondering if you know what kind of sensors the FarmBot uses.
Oh, I don't actually. Yeah, I have no idea. I didn't even think about that. I'm sure FarmBot must have some sort of. Actually, I don't know about that. I know that FarmBot has cameras on it, and part of what it's trying to do is look for things that start to grow not in a place where it planted a seed, and then it like does its little spinner to chop those off. But I don't know how it handles watering cycles. Maybe it's just a strict schedule, or maybe it's based on moisture sensors. I don't know. We should try to invite Connor on and see if he can give us some of the down low on that. Well, my audio issues seem to be growing in number. Todd, if you're able to hear everyone, do you maybe want to just take over kind of mediating and see if anyone else has a project they want to talk about or share?
Yeah, no problem. I'll MC this thing. Does anybody want to jump in? Otherwise, I'm going to ask John, because I know John has at least 4 projects that are halfway done right now that he wants to tell us about.
I have a little project that I could share as well, but John's welcome to go first.
Why don't you go, Aaron? We hear from John all the time.
Yeah, you go for it.
Okay, let me share my screen. Okay, so can you guys see my screen okay?
Yep.
Okay. So yeah, like I was saying in the intro, I've got my neighbor, and we share a barn, and he's got these 2 giant chest freezers in there that one day I went in and I needed to I don't know, plug in an air compressor, and I unplugged his chest freezers, and then that's tons of meat in there. So I kind of got in trouble for that, and I was like, I'm going to build something that's gonna fix that, and let me know, or let one of us know if those freezers get unplugged. So I don't have a picture of it. I guess I wasn't really planning on presenting, but basically what I have is a Raspberry Pi 0W that plugs into a 3-pronged, I guess. It plugs into a like a T, so freezer plugs into one outlet, and then the Raspberry Pi plugs into the other one. So the cool thing is this connects to my home Wi-Fi, and I can and if it loses connection with my Wi-Fi, it sends off an email. And what I'm doing to do that is I'm using Adafruit IO, and this is really cool. So I was thinking I'm going to have to build the application to some sort of notification mechanism, because like really I want to know when this thing loses power, and my Pi itself can't send me that. So this is Adafruit IO. It's free. And you can set up a feed. It uses the HTTP API. There's API docs here that I think.
You know,
Well,
sharing your screen.
oh, whoops. Yeah, let me share my. Okay, share. Screen share. Okay. So yeah, this is Adafruit IO. Okay, there we go. And so what you can do, you can sign up for a free account, and you can have up to 10 data points a minute and 10 feeds. And the cool thing is it does alerting on it. So if I go into my feed here, this is just doing HTTP posts, or my Nerves app is doing HTTP posts every minute. And so it just checks in. But the cool thing is you can go down to this notification section here and say, okay, every let's see, if I don't receive a ping within 10 minutes, or you can set it up to an hour or 7 days. It'll send you an email, which is exactly what I wanted. So yeah, as long as I'm within Wi-Fi range, this works. It'll also tell me when my internet's down too. So yeah, this is the project I built. It's GitHub Aaron Renner /FreezerEye. This is my first adventure into Poncho projects, and I'm curious if people do a lot of Poncho projects. One of the things I found, I mean, I like the idea of having separate folders and different, like the mix or the dependencies are all separate, but then to run like the tests across all of them, or to run dialyzer across all of them, then I had to end up building my own make file. And this thing I kind of lifted it off of the Elixir make files there. But I mean, I ended up making steps for installing dependencies, running dialyzer, checking formatting, stuff like that. But I definitely was curious if people have worked in Poncho projects, and how this is handled. And then also the cool thing was, this is just an Elixir app that's just running on a Raspberry Pi. So I ended up building all of these projects, the FreezerEye reporting that sends the stuff off to Adafruit, the HTTP client, and it all runs locally on my laptop. And since it was such a simple project with no hardware, I was able to just in like 20 minutes throw in a FreezerEye firmware project and make it work, and load it onto a Raspberry Pi once I'd figured out all the rest of the stuff. The other thing that's kind of cool in here is I used GitLab CI as my CI for this pipeline. So there's a whole bunch of different build stages that run in parallel, and I don't have that open. But yeah, this is a really cool project, and also I get to play around a lot with figuring out how to actually build the heartbeat mechanism so that it using OTP so that it recovers from failure and stuff too. And so yeah, this is what I've been working on, and definitely I don't have many pictures, but I'd love to open up to any questions.
Aaron, what's the difference between a Poncho project and an umbrella project? I haven't heard of Poncho before.
Okay, yeah. So a Poncho project is a nerves thing where, let's see, Greg Mefford put that together. Basically, you use sorry, I can't type and talk at the same time. You use path-based dependencies instead of like if you do mix new umbrella, you have an apps folder, and then underneath that you'll have all your applications. But the idea with a Poncho project is if you use path-based dependencies, then you can set config for just your nerves application, versus like you may have different configs for like other apps in your umbrella that kind of all bleed into the same config if you're using a regular umbrella project. Let me find the blog post for that, and I'll post that.
So I've got a few comments on that. Can everyone hear me? Actually,
yes,
more or less. So the last conference talk I did was actually I talked a bit on the structure, and it's essentially like taking away all the magic that happens with umbrella projects in what he's talking about with configurations, which just clash with nerves and running nerve stuff. And so you essentially can run these applications side by side without having to try to mix their configuration, unless you really want to at the top level by making it as part of a dependency. And I have been doing that a lot more lately because I've been taking this local first mentality where any interaction I need with devices or any like UI or something, I'll build into a Poncho project so that I can build and code to it so that it can run from any device. And if I'm in my local network, I can prefer to, and I've got this crazy setup. So I've got a bunch of devices in Erlang distribution, all running that have the same UI. So at any point, I can go to like device A over there's IP address and see the same UI in any other devices it knows about in distribution. Or let's say that's down, I can open up another one of my devices and still get like a whole network picture. And then when I'm sending requests, I'll do lookups first, or like I'll do detection. So if I'm on my local network, I'll just talk directly to the app somewhere on some device rather than going out to the internet, talking to some broker and coming back. And so then I get like super fast responses because I don't have this internet dependency. And so, I mean, you don't need project projects to do that, but it makes it super convenient when I'm developing to develop them kind of side by side, but still as their own separate entity and their separate testability, which I actually like. I mean, you're talking about having a make file, but I like I don't have a crazy testing or dialyzer setup or anything like that. But yeah, it becomes really convenient in that aspect.
Do you use a makefile for yours, or how do you, like, if you have 4 or 5 projects, how do you test, like, run the tests across your whole Poncho project?
Well, so far I don't couple them as heavily. I just like go into the project and like I try to make my tests very targeted. So I just run into the CD into the project and make a test if I need to test it. And I also like when I've got database layers, I separate all out into their own little projects. And so basically I can test like small components. Like that's another thing. I've also taken some of the Dave Thomas approach of making everything modularized or like very small components and lots of them. So testability is like very direct.
Cool. Yeah, that's actually what I did with that, where with that project, where each, like, there's different layers of the project. There's the layer that talks to this API client, and then the layer that actually does the reporting, and the layer on top of that. And I've got it so I can inject, like, I use mocks so that I've got it set up so I can inject a mock API responses to just test like the reporting layer by itself, and then to test the higher level business logic layer by itself, I can inject a mock backend and test that in isolation. Then I've got a full integration tester in there that tests it end to end. I'm not sure if that's what you were talking about, but that was kind of a cool thing that I like doing in there.
Cool. Is that project publicly available, or is that in a private repo? Aaron, that was directed for you, Aaron.
It's publicly available. Let me post that quick.
Okay. I just have a project that I'm working on now that has a need for a heartbeat. So I wouldn't mind just trolling in there and seeing how you solved it.
Yeah, absolutely. Let's see.
Okay, anybody else have any questions for Aaron? Otherwise, we can move on to see what John's been up to. No? Okay. John, you're on. Thanks, Aaron.
John has not been up to much except, this is my latest. I don't know, can you guys even see this fancy setup? And this fun little module board. This is a, what's the number again? MCP 2515. It's a CAN bus communication module with just high and low signals. And so I can like jab these little ends into the OBD port and start sniffing messages that are being sent across my car and doing fun stuff. That's about the extent that I've gotten to. And I have it, right now I'm using a little Arduino Nano. I do have some code where I'm using a Nerves device to handle that communication, but it's like basically anything like this already exists in the Arduino world. So it's super easy to just do a Google search, and just like Aaron was saying, in 10 minutes, you've got the sample file, you just burn it onto some little Arduino device, and then all of a sudden you're up and running. And then you got to like reverse engineer it to figure out how to, do it more in the Elixir world. But that's pretty much it. I can call out and ask the car to give me like status information, and see, like, I can get the speed of my vehicle, though I haven't done it while driving, so it's just always 0. But that's pretty much it. Hopefully I'll get to the point where I can start feeling confident that I can send messages and have my car do stuff. Like maybe adjust some radio text, or I've got these folding mirrors and I want them to automatically fold in and out when I stop the car. So that's the first route.
Wow.
And I guess the only other project, I can't showcase it, but it uses pin number 4 on a Raspberry Pi to send radio signals and do replay attacks, which replay attacks is like kind of a harsh word, but like a lot of components in your house use radio for communication. If you have a remote for your ceiling fan, or if you have a remote for an air conditioning unit, or maybe lights or something, that's typically using radio to communicate back and forth at 433 megahertz. And I think I talked about this a little before, but you can get one of these little dongles, which is a software-defined radio dongle. You can record the signal of the remote, and then you can replay that signal back. But there's this cool library that will use pin number 4 on a Raspberry Pi with just whatever length wire you need for the frequency. And so you can just you don't need any other hardware. You just put a little wire on that Raspberry Pi pin, and then you can replay these radio signals. So I have this little library that I'm going to publish here in the next few days, hopefully. And I have an article write up about it, to just walk through how you can record these signals, and then how you could make on a Nerves device something where you can add a button and elicit or control your, anything that's controlled by radio in your house, without any extra transmission hardware. That's actually really super cool. The only thing I have though that uses radio is all the way literally the other end of the house. So I usually have I steal my wife's phone and I start a FaceTime session, and then I'll watch it over here, and she'll just be seeing the lights turn on and off every couple minutes while I'm playing with these signals.
So GPIO4, what's special about that pin? It's a clock pin, or is it PWM pin?
GPIO4 is, I always forget.
I didn't see anything special about it. It says GPIO_GCLK, which I assume has something to do with the clock.
Yeah, so it's usually the clock. You can use 4 or 20 or I think 6. No, not 6. That's ground. No? 6. There's a few pins you can use because they do have clock. That's what it is. They can do that clock. GPIO4 is usually what you use with stuff that's like a one-wire protocol. Like a lot of temperature sensors will use one-wire protocol, so that you can have multiple items on the same wire, and it can differentiate between signals. And I guess the guy who made this library, that's just the most frequently used and the one he recommends. But yeah, so I compiled all that down into these binaries, and then I put these binaries into a Nerves image, and I just make system calls out to this binary with a file path of my recorded signal to then kick it off and say, run this, and that radio signal turns something on. The only downside is these like radio devices in your home are really dumb. There's zero feedback. So anything that happens with it, it's just like a fire and forget it. So the library will be like fun as a learning, or if you want to use it, but like there's no validation that your command worked or not. Or you know, if something's in, you can't get the state of the device. Like you can't tell if it's on or off, because most of the time it's just like a binary state. Just only the controller knows, and when it gets the same signal, it just knows to, if it's on, flip it off. If it's off, flip it on, kind of stuff. But it's super fun. I'm actually really excited for this one. I've got some capacitive touch buttons. We have this headboard on the side of our bed. I'm going to put a little nerves controller there with all these touch buttons to then elicit the different fan actions and turning the light on and off. Because the crux of a fan with a remote is that the fan's on during the day, and at night when it's dark, you flip the light switch and there's no light. So I'm going to control that thing with my voice and buttons on my headboard.
Wow. Okay. You'll never have to get out of bed ever again.
I do have some Nerves devices working with Siri too. That's been fun. Maybe I should have prepped that.
All right. Well, we'll hope for that next month. I think some other people have been working on Siri stuff and Alexa stuff. So it'd be great to see that. Anybody else got anything going on? Benjamin, you got any projects coming up or anything you got on your mind thinking about building?
Not at the moment.
Nope. Hoping for some inspiration. Manuel,
Yep.
I know you worked on some under cabinet lighting. You want to talk about that at all? Or it sounds like that has been going well.
Yeah. I mean, it's not complete. But I'm working on a write-up that hopefully before the next, I should have it up before the next meeting. But no, it's a small extension to what I demonstrated last month with my on-air light. This is just multiple nerves lights listening over MQTT. And then Home Assistant, controlling those through MQTT.
So Home Assistant, you've got, I don't want to spoil your write-up, but you've got multiple Nerves devices, like one for each group of cabinets, and then they're communicating through that COM bus to each other so they can all work at the same time in coordination with each other without ever connecting wires between two groups of cabinets, right?
Right. So, MQTT is kind of a pub sub, message protocol for IoT devices. And in Home Assistant, they're set up as individual lights. So you can set up a group of lights. And so Home Assistant takes care of, you turn on the group to some certain color. It'll broadcast out to each one of those topics. And so each one of those Raspberry Pis are listening to their own topic and then reporting back.
Very cool. All right. Ganesh, what do you got going on? Do you have any, you said you had a Raspberry Pi 3 that you were getting up and running. Did you have a project in mind for it?
Yeah, basically, I mean, I'm just playing with the Phoenix, and I wanted to take it. I want to see if I can run live view, something interesting on that. More like a dashboard.
Okay. Using Nerves, like a kiosk setup, or just like a regular?
Yes, I mean, it just attached to my Raspberry Pi, and I could be doing something. So that's why I started. I started simple.
Cool. Yeah, something to get you, keep your juices going. So
Yes.
I recently converted my smart mirror over to live view. So I was using channels before to update the weather dashboard. and like the weather forecast every 15 minutes. And so recently switched that and the clock actually over to live view. So the clock was running just a regular JavaScript, like vanilla JavaScript on the front end, but it was so easy to the live view transition was so easy with the weather stuff. I decided to redo the clock in live view as well. So shout out to Eric Ostrich from Smart Logic for helping me out with that, if he listens to this.
Yeah, nice. Yeah.
So yeah, hit us up if you have questions. Hit us up on the Slack channel.
Yeah, sure.
All right, Michael. I think that's everybody. If you want to finish us up.
Sure. I don't have a lot to add. So I was actually watching the live stream on YouTube. So I'm like 30 seconds behind, but I actually was able to catch almost everyone's projects. I just want to say a big thanks to everyone for making time to come and get together, share your projects, share everyone's progress. For me, it's super exciting just to hear about all the things everyone's building. I hope my project and my consistent failures for watering plants don't bum anybody out too much. Really, I mean, building things in the real world, if you've been spending your whole life building software that just does bits and bytes or just paints screens in web browsers, it really is magical. Even when I completely fail, it's a magical and different kind of experience. So we'll get continued updates next week. I think this is probably a good time to wrap it up for this month. Thank you again, everyone. Sorry for the audio issues. I'll try and get that, maybe just not use Safari next month for the meetup, and we'll try and get those ironed out. But thank you again, everyone, for making time. And anyone that's watching this after the fact, feel free to tweet at us. You can find all the people here. The easy one to remember is Nerves Meetup on Twitter, or we have a Slack, and everyone's welcome to come in there, ask questions. A lot of us are also in the main Elixir Slack and the Nerves channel, so you can hit us up there as well. We hope all of you guys find, everybody who's interested can find a project that is fun to build, something to learn with, something to grow your skills a little bit, and have a chance for your code to affect the physical world. So I guess that's it for this month. Thanks again, everyone, and we will see you next month.
See you.